In 2005, the film Stealth hit theaters, dazzling audiences with futuristic dogfights and jaw-dropping aircraft. The real star? The FA-37 Talon, a jet that looked like it belonged in 2050, not the present. Its most striking feature wings that could sweep forward for stability or swing back for supersonic speed. The Talon's design was so convincing, it blurred the line between science fiction and reality. Aviation fans wondered, could something like this actually exist? The answer is more fascinating than fiction. The FA-37 wasn't just a Hollywood fantasy, it was inspired by real classified research. Hollywood often consults aerospace experts for authenticity, and Stealth's designers found inspiration in a radical Northrop Grumman concept. The Talon's morphing wings were a cinematic exaggeration of a real engineering challenge: how to make one jet excel at both slow and fast speeds. The film's aircraft gave us a glimpse into the real puzzle of variable geometry wings. The Talon's story is more than movie magic, it's about bold ideas and the quest for the perfect flying machine. Sometimes the most futuristic concepts are already being explored in secret labs. The FA-37 Talon reminds us that the boundary between imagination and innovation is often razor-thin. What we see on screen can be a window into real engineering dreams. The Talon's legacy? Inspiring us to ask, what if the future is already here? And sometimes it just takes a blockbuster to reveal it. The FA-37. Talon's real-world inspiration was the Northrop Switchblade, a radical 1990s concept. Northrop Grumman's advanced design team envisioned a jet that could physically change shape mid-flight. The Switchblade's unique scissor wing could pivot, transforming from a straight, stable wing for takeoff to a sleek, swept shape for supersonic speeds. This wasn't just for show, it solved a real aerodynamic problem. Northrop patented the idea and built wind tunnel models, proving the concept had potential. When Stealth's producers found this declassified design, they saw its cinematic potential and brought it to life as the Talon. The Talon's forward-swept, variable geometry wings are a direct homage to the Switchblade. Both aim to create a jet that could excel at any speed with a single, transformative solution. The Switchblade never flew, but its spirit soared on the big screen. It's rare for a top-secret military idea to debut in Hollywood before the real world. Through the Talon, the Switchblade's legacy inspired a new generation to dream about the future of flight. Sometimes the boldest ideas find their wings in the unlikeliest places. Aircraft design is all about trade-offs, especially when it comes to wings. Long, straight wings are perfect for slow flight and tight turns. Think gliders. But at high speeds, those same wings create massive drag, making supersonic flight inefficient. Supersonic jets need thin, swept-back wings to slice through the air. This creates a dilemma. Do you design for low-speed agility or high-speed performance? For decades, designers had to choose one and accept the limitations. Enter variable sweep wings, wings that change angle in flight, adapting to any speed. The FA-37 Talon and Switchblade took this idea to the extreme, reconfiguring their entire aerodynamic profile. Morphing from a stable, high-lift platform to a sleek, low-drag dart is the holy grail of aircraft design. It's the dream, a jet that performs brilliantly at any speed, without compromise. Achieving this requires complex engineering, but the payoff is unmatched versatility. The Talon's wings weren't just movie magic, they represented a real quest for aerodynamic perfection. The future of flight may depend on mastering this balance. For most of aviation history, stability was king. Planes were designed to fly straight and level on their own. But stable jets are sluggish in combat, resisting quick maneuvers. The digital revolution changed everything. Engineers realized they could design intentionally unstable jets, agile but impossible to fly by hand. Enter fly-by-wire. Computers interpret the pilot's commands, making thousands of micro-adjustments per second to keep the jet under control. This breakthrough unlocked incredible agility, and allowed designers to focus on performance and stealth, not just stability. The F-117 Nighthawk was a perfect example. Its stealthy shape was unstable, but fly-by-wire made it flyable. Suddenly, complex mechanical solutions like swing wings seemed less necessary. Modern fighters like the F-22 and F-35 use fixed wings, but advanced flight controls and powerful engines let them perform at any speed. The digital revolution shifted the focus from moving parts to processing power. Why build heavy, complex wings when software can do the job? The result, lighter, more reliable jets that push the limits of what's possible. Sometimes the best solution isn't mechanical, it's digital, and that's changed the game for fighter design. Despite its promise, the Northrop Switchblade never left the drawing board. The reason? complexity, and risk. A massive, pivoting wing would have been heavy, mechanically intricate, and prone to failure. Bad news for a combat jet. Maintenance and reliability concerns made the military wary. Meanwhile, advances in digital flight controls, thrust vectoring engines, and composite materials offered simpler solutions. The world moved toward digital elegance, leaving the Switchblade's mechanical marvel behind. The idea wasn't flawed, just overtaken by faster, more practical technologies. The Switchblade became a what-if, a glimpse of an alternate future. But its legacy lived on, not in the skies but on the silver screen. The dream of morphing wings didn't die with the Switchblade. Today it's more relevant than ever, especially for drones and hypersonic flight. Morphing wings could let drones take off with high lift, then transform for long, efficient loitering. NASA and others are developing lightweight, flexible wings that change shape without heavy joints. Projects like NASA's MADCAT aim for bird-like, seamless morphing using smart materials and actuators. Hypersonic flight brings new challenges. Tiny shape changes can have huge effects at extreme speeds. A morphing airframe could bridge the gap between slow and hypersonic flight, making future aircraft more versatile. The Switchblade's dramatic scissor wing may be sci-fi, but its core idea is alive and evolving. The future of flight will be adaptive, dynamic, and smarter than ever. Movies like Stealth aren't just entertainment, they can spark real innovation. The FA-37 Talon and Northrop Switchblade show how reality inspires fiction, and fiction inspires the next generation of engineers. Stealth took a secret concept and made it famous, planting seeds in millions of minds. Imagination and engineering feed off each other. Jules Verne dreamed of the moon long before Apollo. The Talon visualized a bold idea, keeping morphing aircraft alive in our collective imagination. Today's engineers might recall the Talon's wings and ask, how can we make that real? Fiction turns dry diagrams into thrilling possibilities, fueling creativity and progress. Innovation isn't a straight line, it often detours through our dreams. The FA-37 Talon began as a secret proposal, became a cinematic icon, and now echoes in cutting-edge research. Sometimes the future takes flight on the wings of a good story, and that's the real power of a brilliant idea.